Alright, today we're solving Leetcode's longest palindromic substring. Given a string S, return the longest palindromic substring in S. Example 1, we have an output of BAB, but ABA is also a valid answer since they both have a length of 3. Example 2, the output is BB. The constraints tell us that the input length will be greater than or equal to 1 and less than or equal to 1000, and the string will consist of only digits and English letters. A palindrome is a sequence that's the same forward as it is backwards. Another way to think about it is the left half mirrors the right half. So if we think about it that way, we can start to come up with a dynamic programming approach where we iterate through the string and treat each letter as if it could be the center of a palindrome, and expand from that center to the left and right of it. This solution has a big O of n squared time complexity and O of n space complexity. The benefit of this approach is it allows us to not have to check every single substring. We're only checking from the center of a potential palindrome. Here we have an example input string of BABXAAX. We'll start by initializing a variable called currentLongest that we will assign the starting and ending indices of our potentially longest substring. So to start, we'll initialize it with the first character because a single character is a valid palindrome and our constraints told us we will have a minimum of 1 character. This gives us a starting index of 0 and an ending index of 1. We're going to be using these indices to slice the longest substring at the end, so remember, the slice method slices from the starting index up to but not including the ending index, so a slice starting at 0 and ending at 1 will return the first character only. Next, we'll loop through the string starting at the first index, which is the letter B, and we'll check if the character to the left and right of it are equal to each other, which they are, so right now we have a palindrome of length 3. We expand one more index to the left and right and perform the same check. In this case, one more index to the left we're out of bounds, and one more to the right we have the letter X, so we can stop our checks here and update the current longest with the starting and ending indices of the substring BAB. Now, we can't move on yet. An odd number length palindrome will center on a character, but an even length palindrome will center between 2 indices. So before we increment to the next index in our loop, we need to check for a potential palindrome centered between B and A. We ask, is B equal to A, which it's not, so we can move forward in the iteration to letter B. We check for an odd length palindrome. A is not equal to X, so we check for an even length palindrome centered between A and B. A and B are not equal, so we iterate to the next letter X. B and A are not equal, so there's no potential odd length palindrome here, and B and X are not equal, so there's no potential even length palindrome here either. So the loop iterates to the letter A. X and A are not equal, and if we check for an even length palindrome, we get X and A again, so the loop iterates and we have another letter A. A is not equal to X, so we check for an even length palindrome centered between A and A. A is equal to A, so we expand one index to the left and right. X is equal to X, so again we expand one index to the left and right, which gives us B and out of bounds, so we stop our checks here and update our current longest indices with a starting index of 3 and an ending index of 7. The loop iterates to the letter X. To the left we have the letter A, and to the right we're out of bounds, so we check for an even length palindrome. A and X are not equal, so our checks end here. The loop iterates out of bounds, our for loop exits, and we return the substring slice of our current longest indices. Let's translate this to code. Okay, we'll start by initializing a variable called currentLongest with the starting and ending indices of the first character. Next, we'll set up the for loop to start at the first index. Now we're going to set up a helper function that we're going to pass to it the string input and the left and right index of our possible center. For an odd length palindrome, the left index is just our current index minus 1, and the right index is the current index plus 1. For an even length palindrome, the left index is the current index minus 1, and the right index is just the current index. Okay, now we're going to set up our helper function. Our helper function is going to contain a while loop that will iterate as long as the left index is greater than or equal to 0, and the right index is less than our input string length. Remember, we're expanding to the left and right, so if we expand past the 0 index to the left, or if we expand past the last index to the right, then we'll break out of the while loop. Inside of the while loop, we'll check if the characters on the left and right of our center do not match. If they don't, then we're just going to break out of the while loop. If they do match, then we're going to decrement the left index and increment the right index. Once we break out of the while loop, we'll return the starting index and ending index of our potential longest palindrome. So why is it left index plus 1? Whether we break out of the while loop because one of the loop conditions evaluates to false or because the if condition triggers, will be one index too far to the left. We need to add 1 to it in order to get the correct starting index. So if we're adding 1 to the left index, why aren't we subtracting from the right index? Remember, the slice method excludes the ending index, so even though we're also one index too far to the right, that ending index will not be included in the slice substring, so we don't need to subtract one from it. Now that we've calculated our potential odd and even longest palindromes, we need to compare their lengths to see which one is longer. So we'll take the ending index of both and subtract the beginning index and return whichever is greater. Next, we need to see if the longest palindrome we just calculated above is longer than our current. If it is, then we're going to update it with the new longest palindrome indices. If not, we're just going to return the current longest. Finally, once we exit the for loop, we'll return the substring slice of our current longest indices. And that's our solution. Let's copy and paste this in a Leetcode. Okay, let's paste it in here, hit submit, and we get an accepted solution. Thank you for watching.